I wanted to talk about the role of a designer as somebody who sees things differently. I think it's very important for us to understand that when we think of immersive technology, we're not just thinking about consumer products or entertainment. We're also thinking about the design craft of tools, new ways of seeing. Many of you will have heard of Pokemon Go, I'm sure. It is a massive game playing session that's taking over Europe, North America. I believe here many people might play City Spirit Go by Shenzhen Tanu Technology. What I think is interesting is how interaction can help us understand new ways of using these technology. Augmentation is a layer over reality. That's what Pokemon Go does, for example. Emulation allows us to go to other worlds. But what I'd like to talk to you about is exploration. That is, what can we see differently? How can we make things that are invisible visible? This is, for example, is a Pokemon Go. We have a little character popping up. He augments our existing reality. But I actually believe that our existing reality is a precious, amazing place and that it is very much worth a deeper look. I wanted to talk a little bit about a definition. Many of you will have heard of cyberspace. So cyberspace is a consensual hallucination. Many people imagining, seeing, visualizing the same thing at the same time. That's what Pokemon Go looks like right now, by the way, in North America. This came from William Gibson. William Gibson's a writer. He wrote Neuromancer. But he also said something very interesting. He also said that cyberspace is a graphic representation of data. And that's what I'd like to look at today. He talked about it being in an unthinkable complexity, that it is like light ranged in the non-space of mind, that it isn't a cluster and a constellation of data. So I wanted to talk a little bit about some of the work I do. I do work with many students in interaction design. And the number one question I get from people is, well, what is interaction design? I like to say it's the human experience of digital products and services. But what it really is the human experience. Most importantly, of other humans and of the world around us. So this is an example actually of a piece of software I designed and developed for a startup company. This is a type of project that may take a few months. What was important here was that I noticed that when young people were sending messages to one another, they were only using one thumb. So the inspiration for the interface was to actually just use a dial that could be used with one thumb. So many people this morning and this afternoon have talked about empathy, understanding users. This came from hundreds of hours of looking at users. It's something that's been part of my practice since I first started designing. So today, one of my principal jobs is to educate young people who want to become interaction designers. This is Jeff Guo, originally from Beijing. And here he's practicing physical interaction. Many people think of interaction as simply screen-based. That's an interface. The interaction happens between people, between systems, between things. And our students are pretty fearless. Here's Angela. She's learning how to solder because physical interaction now takes place on our bodies, on our clothing, increasingly in our vehicles, and it's also taking place in what I call an ethical algorithm. The interaction is taking place in an invisible interface. That's what happens when your car makes a decision for you. It's interacting with you, but there is no interface. So what has been precious to see is the way that our students grab a technology, make it their own, and then answer a design brief. And in this studio, which I teach, this is called Play Studio. And the goal is not to design a game. The goal is to design a human being's experience of play. what's tricky here is that to get an A, you have to observe somebody smiling, laughing, and sharing it with another human being. You can't pitch, you can't present, you can't explain. As a designer, you have to demonstrate. You do not come wrapped up with your own design and software. Let me click through a few of these. This is Periscope, obviously, just as you expect in your building. And the one down at the bottom is actually Ting Wu's senior project piece. And Ting designed a way for people to capture their body, go through a kind of immersion environment. The other person starts playing with what looks like a great big telescope. And the goal is really to have the two people interact with one another. So increasingly, our students are grabbing new technologies. This is an example from Philip Kostick. Philip is a fine artist, and here what he's doing is he's playing with the discovery of different visually designed immersive spaces in a room. He's using an HTC and a Vive, which is interesting since it allows us to capture his body at the same time. So why is this important? I think this is important to look at how we use interaction design, human-centered, driven, systematic, and iterative, from sketching to prototyping methodology, to understand what humans need. So really what we're doing here is we're asking questions of the world. Will she say yes? Does a rock dream? Can I win? Question I'm asked oftentimes by our automotive partners: what will the human experience be in an autonomous, connected, networked vehicle? And what interaction language is meaningful? I started my career a long time ago, it feels, over 20 years ago. The platforms then were things like CD-ROMs, video discs, ATMs, a thing in France called the Minitel. Those platforms have changed. I feel my job as an educator and designer is to support people in a creative methodology that no matter the technology, they're going to have the tools to understand them, to master them, and to be innovative in them. So I actually wanted to jump back, way back in time, and we're actually around 170 AD. This is Ptolemy. Not an interaction designer, but what he did do was he designed a way of thinking about the cosmos. Some of his celestial movements are incredibly beautiful. The idea of a universe in harmony. This graphic here was done by Solaris. And the problem with this is the graphics are beautiful and the science is wrong. And for 1,500 years, people believed that this is the way the world worked. They believed this is the way the cosmos worked, because that's what they could see. Now, 1,500 years later, Newton thought differently. And I like to think that it's not just because he was brilliant, but because we had a revolution in optics. We had a revolution in the technologies that allowed us to see the world differently. Here we have the first example from Sutherland, or virtual reality. But what I think is happening is that sophisticated technology can emulate reality. We can create immersive storytelling environments. But I'd like to invite us not to forget the opportunity to see our natural world very differently. We're at a tipping point. Things like virtual and augmented reality are going to disrupt many, many sectors: research, sports, military, education, entertainment, car manufacturer. But I think that if we don't bring to it some of the human qualities about why do we do this, what do we see differently, and why does it matter, I think we're actually missing an opportunity to ask some interesting questions. So I run a project with Caltech, which is a science university in Pasadena, and NASA JPL, the Jet Propulsion Lab. And our goal over the last few years has been to design tools that allow scientists to do science differently. So I wanted to show a few examples. This is actually a physical installation. It is called LIGO, which is a shorter term for an interferometry wave observatory. And what this really does is it listens for the sound of a quantum wave, a gravitational wave. Now, one of the exciting things about being a designer is you don't have to understand everything about the world, but you have the chance to go and explore it. So by asking some very simple questions, how does this make meaning? Who uses it? How do you communicate it? As a designer, we get to do a little bit of detective and investigative work. So what the LIGO does, as far as I understand, is according to Einstein's theory, there will be a wave produced when two black holes collide. Now, as a designer, that's pretty exciting stuff, right? You're like, how come I get to be a part of that? Now, what happens is they have built two lasers, these two long lasers, and there are several sites like this in the world. Those lasers are finely tuned so that when that gravitational wave hits the Earth, the laser will be interrupted, and they'll know that this thing predicted but never observed by humanity has actually happened. So this is thrilling. And as a designer, felt very overwhelmed and very privileged to have scientists explain this. And then I went into their office. This is what they see. This is what they're looking at. And of course, as designers, we all stood back and went, "Ooh, this is not okay. This is not what we need as, people who live on the planet to be looking for quantum waves." So we asked, what are all these things? What does each color mean? Each line? We really were pretty thorough. And what we wanted to do was to investigate the outliers, not to change the science itself, but to understand what makes that information meaningful. So what we had to do was to really codify all of those hundreds of data channels, try to reduce the cognitive overload, actually look for patterns, try to see why they were drawing relationships between different pieces of data and why. And most importantly, in this case, start to build a visual language that would be meaningful for them. So what we did was we built a customizable tool, right? And we realized that the energy waves were not just going along the way, they were actually going round in a time-based metaphor. And we put what's called the Dharm wave on the outside, and we started bundling all the data and put the data that was most important in different blocks, and then we sub-categorized those blocks, and we put the main wave that will recognize the Dharm around the side. You can drill down. Important things about any data visualization, you have to be able to sweep across it, recognize, drill down, and then get the raw data. They're the three kind of building blocks. And I thought the scientists would understand what it was they were looking for. And they're not, they're very human. They're like, I'll know it when I see it. I'm just investigating. Because for them to be innovative, they have to be able to play, to look, to share, and to brainstorm. Not just create illustrations of the science that they found out. So this is another screen from this that shows what it's like when you actually go down into the middle. For anybody who's interested, it's built in C++, it's open source code. You can find this on the web. I can give you the information a little bit later. But our next challenge the next year was a little bit interesting. How can you transform what you can't see? And I was very shocked to discover this. Rover on Mars is virtually blind. And we discovered this when we went to see how could we build tools that would help the people who drive Rover on Mars from NASA. How can we help them better design tools to actually drive Rover? So when I was first asked, how do people drive Rover? I was like, I don't know. I imagine they've got a big joystick and a lot of popcorn and it's just amazing. And they were like, no. What we do is we actually build code. We write raw code. It's called a command line. We submit it to an engine. The engine runs the command line and shows us a picture. And then we tweak it, we tweak the code, and back and forward, back and forward. And this takes a whole day. And on Mars, a day is a sol day. It's called a sol. So what they do is they actually upload the instructions the night before, and the next sol, little Rover goes out and does what it does. But the challenge for Rover is Rover can't see where it's not. It can only literally have little sensors right around it. So because of all this, at first it took NASA and JPL about 3 years to do 10 kilometers. Now that's not very far. So again, we started to think about how we could help Rover. And we realized this is what Rover sees. Rover sees rocks, Rover sees slopes, and Rover sees sand. Now, for those in the automotive world, they know that actually creating a vehicle that can cross terrain is not easy. And these were the primary variables that allowed the drivers to recognize whether they were in the right place. So what we did was we decided that rather than use this 2D environment that they were typically using, we wanted to actually nestle, to overlay the content on the map and to create some tools that would allow them to actually do it. So what you're seeing here is part of the tool set. It allows you to drop a pin, move the pin, see the variables, decide which overlay you want to see. Is it slope or pitch and roll or uncertainty? And when that happens, you see that it updates in real time. So again, we're trying to transform what we can see into a tool set we can use. We're helping Rover see, and we're hopefully trying to supply the actual drivers with a new way of being on Mars. So what was the next set of problems we chose to look at? We realized or learned human factors are incredibly important when it comes to creating immersive realities. The human eye in a 2D sees 1 kilobyte per second. And the human eye, the human brain, can only process so much. But when we were looking at those degrees, those numbers of variables, when we're looking at data to the power of in an exponential way, we actually need to be able to find another way to give that amount of information and allow people to make decisions. So the project that we were looking for was the need for a tool that can see in approximately 5 dimensions. And I'm going to try and explain this best I can. This is about neutron scattering. So neutron scattering is a technique that is used in materials science. You fire off a little neutron against an object, and depending on how it moves away, you get to understand some of the fundamental material values of the substance. So for example, it allows you to fire off a piece of silicon and understand what is the heat, the movement, the stress that that piece can take. Now you can imagine that this is how material scientists discover material. It's how they test composite materials to better understand their capabilities and their uses. And this is what they were seeing. And as you can, well, some of you may be able to read this, but one of the challenges with this is you have no sense of the 5 dimensions. So what we try to create for them is a tool. And in this tool, the energy is an angle. There are different types of energy, but we actually used angle to show this. We used color. Intensity is the length. And we also created tools that would allow them to navigate this and to compare and to embed the tools in their everyday usage. For example, seeing those different temperatures. So you can imagine how it is to be a scientist inside your model. They don't know what they don't know until they see it. So as I mentioned, I invite you to think of innovation as, first of all, creating tools, not just new content and new technologies, but also as a different way of looking. So some examples I think that might be interesting for us to see more of are from other places, right? This is from Masters of Pi. It's a cube experiment, and they're actually looking at DNA. But what they're actually allowing the user to do is to step inside the menu and navigate the content by moving their body, but they're also allowing them to see the dimensionality of the actual data that they're interested in. Right? That 360-degree canvas allows them to see, in this case, the mechanism by which DNA curls upon itself. There are some other examples that I think would be very interesting for this audience, and they're from the Human Brain Project, and there are a number of them available online. But what I think is fascinating is the fact that there are companies that are starting to use these techniques. Some of our colleagues in automotive, for example, use them to actually visualize the vehicle from inside and out. But we're starting to see people use these tools to actually understand data and move through data in a different way. Our friends at Oculus Rift are actually working with Salesforce.com, as are the NASDAQ, which is the stock market. And I think what I'd like to call our designerly attention to is that these tools are made with the end user in mind. They're made with data scientists and engineers and scientists and the general public. One of the things that's changed in the time that I've been a designer is that in interaction design, there is no star designer. The job as a designer is to facilitate, to encourage your end user to participate. And it's very humbling as an interaction designer. I can design this interaction, and if nobody engages with it, the interaction doesn't happen. It's a philosophical question maybe, but what I created does not exist without the other person participating, without a user. And that is a methodology that informs all of our design. When we talk about human-centered design, we mean really understanding what the human impetus for the task, for the innovation, for the communication, for the relationship, what it is and why it matters. So I invite you to just really pay attention to your opportunities as designers to actually create for others, where engaging others is your job as a designer, and that the innovations that you give to them can allow them to do everything from discovering new minerals, molecules, potentially seeing on Mars, intervening in big data in a way that allows them to make decisions and design support for other people. And I think this opportunity to immerse ourselves in three-dimensional tool sets is a place that is ripe for disruption. So with that, I just wanted to leave you with the idea that, as I mentioned, you can't design really what you can't see, or you can't transform what you can't see. And there are many ways of seeing. Seeing differently means that you have to build certain tools so that you can manifest your design intent differently in the world. So with that, I'll just leave you with a few thoughts. Interaction is not the interface. Interfaces change, they come and go, according to technology platforms. That think about the capability you're creating with a virtual or augmented reality, not just the content. You're basically giving a scientist in our project work, giving them a superpower. Think about showing the invisible and a belief I have is that when we talk about big data comes in a set. It has to be architected and designed just like any medium, just like any entity. And I believe that when you put the two together and that you actually ask a wicked question being a complex question, a question with no single answer, but a multiplicity of opportunities, I actually believe that you will be able to innovate and you'll be able to create change in the world as you see it. Thank you.